Hello friends, in the previous lecture we have seen that what is my matrix notation of linear system. Also we have to study example 1 system of linear equation. How to solve the system of linear equation by using elementary row transformation. So today we have to get one more example on system of linear equation. So that our equation solve the following linear system. Solve the following linear system. Solve the following linear system. Your first equation becomes x2 plus 4x3 equal to minus 5. This is your first equation. Second equation becomes x1 plus 3x2 plus 5x3 equal to minus 2. Okay, and your last equation becomes 3x1 plus 7x2 plus 7x3 equal to 6. Okay, so we are given this system of linear equation. In that system of linear equation there are 1, 2, 3, that is 3 equations, and how many unknowns? Unknowns means variables x1, x2, x3. There are 3 variables. Okay, this is system of linear equation in 3 equations and 3 unknowns. Okay, we have to solve this system of linear equation by using elementary row transformation. So let us write some solution. Here consider augmented matrix. Consider augmented matrix for given system. Consider augmented matrix for given system. That is your augmented matrix is AB. Okay, what is your augmented matrix? It is augmented matrix AB. What is augmented matrix? Consider your coefficient matrix and your right hand side become column matrix of constants. Okay, what is your coefficient matrix? So value of x1 become 0. Okay, value of x2 become 1. Value of x3 become 4, and value of constant, that is your minus 5. Second row become 1, 3, 5. That is 1, 3, 5. What is your constant? Minus 2. And your last row become 3, 7, 7 and 6. Okay, so this is your augmented matrix AB. Okay, now we have to solve this augmented matrix AB. What is your first step? We have to do this coefficient matrix A. This is your matrix A, right? And this is your column matrix your B. Okay, so we have to make this coefficient matrix A. We have to do this matrix into upper diagonal matrix, and we have to make all diagonal elements become 1. Okay, so we have to make this first element is 1. For that process we have to interchange first and second row, then we get this entry become 1. So what is your row operation? We have to take R12. What is by R12? R12 become, that means we have to interchange first and second row, then we get augmented matrix become, your first row become, that is 1, 3, 5, right? And your constant become minus 2. Your second row become 0, 1, 4, right? And your constant become minus 5. What is your third row? Third row is 3, 7, 7 and plus 6. Okay, now next step we have to make that 2 entry, that is A21 and A31 entry become 0. So this entry already 0. We have to make that A31 entry 0. So how to make this entry 0? That is, this entry is 3. We have to make this entry is 3. How to make this entry 3? Multiply by 3, right? And then take the subtraction. Then 3 minus 3 become 0. So what is your row operation? That is R3 minus 3 times of R1, right? Then we have to make this entry is 0. So then your augmented matrix become your first and second row as it is, that is 1, 3, 5, and this will become minus 2. What is your second row? 0, 1, 4. This minus 5 as it is, right? And what is your last row? That R3 minus 3 times of R1, that 3 minus, and this minus 3 into 1, that is minus 3, and 3 minus 3, that is 0, right? So we are given this is 0. Then 7 minus 3 into 3, 9, that is minus 9. 7 minus 9, that will become minus 2, right? Again 7 minus 3 into 5, that is 15, and 7 minus 15 is minus 8. Again last 6 minus this minus 3 and this minus 2. Minus 3 minus 2 plus 6, and 6 plus 6, again 12. So this entry become 12. Okay. So what is next step? We have to make A2 to A2, that is second row and second column entry become 1. So this is already 1. We have to make below that entry, that is A3 to entry. We have to make that entry. We have to make that entry become 0. So how to make this 0? This is minus 2. When A is plus 2, and after taking addition, minus 2 plus 2, 0. So what do you know process? This is entry is present in say third row plus 2 times of R2, right? This entry present in third row. So this your R3 plus 2 times of R2. So your first and second row as it is, right? So what is your first row? It is 1, 3, 5 minus 2. Second row is 0, 1, 4, and this is your minus 5. So what is your last one? 0 plus 0, 0, right? Again minus 2, R3 is minus 2, plus 2 into R2 is 1, 2 into 1 is 2, and minus 2 plus 2, 0. So this entry is 0. Again R3 is minus 8, plus 2 into 4, 2 into 4 is 8, minus 8 plus 8, 0. So this entry is 0. What is the last one? This is 12, right? 12 plus 2 into minus 5. 2 into minus 5, that is minus 10, and 12 minus 10, that will become plus 2, right? So this is your argumentative matrix, right? Now from that your argumentative matrix, what is your next step? We have to, next step, we have to do this first, second, third row of the coefficient matrix A multiplied by x1, x2, x3, right? After equating, so done. After equating both sides, then we get, after equating both sides, then we get equations. Then we get equations. What is your first equation? x1 plus 3x2 plus 5x3 equal to minus 2, right? So that after equating both sides, then we get, what is first equation? That is x1 plus 3x2 plus 5x3 equal to minus 2, called equation 1, right? What is the equation? 0x1 plus x2 plus 4x3, that is x2 plus 4x3 equal to what is the constant? Minus 5, called equation 2. What is the last one? That all these three entries are 0, right? So from that all these three entries, so what do we get? 0 equal to 2. What is this one? 0x1 plus 0x2 plus 0x3. Here value of coefficient of x3 is 0. So we get 0 equal to 2. So is it possible? So this is not possible, right? So from that system we get a triangular form. So this system has no solution, right? Okay. From the last third condition, what do we get? So we get 0 equal to 2. So which is possible? No. So no. Which is not possible. Which is not possible. Therefore, given system has. Therefore, given system has. So which is not possible. Therefore, given system has no solution, right? Therefore, given system has no solution. If system has no solution, therefore given linear system is inconsistent, right? Therefore given system of linear equations is inconsistent. So given system of linear equation is inconsistent. Okay. So let us write on the second example. So it is so easy. So we have to take the one more example. So write on the second example. Determine the value of x. Question 2. Determine the value of small h. Determine the value of small h such that the following matrix is augmented matrix of consistent linear system. Okay. What is the question? Determine the value of s such that the following matrix is augmented matrix of consistent linear system. So your given matrix is augmented matrix is first row is 1h4. Your first row is 1h4 and second row is 3 6 8. Okay, this is your augmented matrix. So in that your augmented matrix we have to find the value of h. Okay, we have to find the value of h such that the given augmented matrix is consistent. Okay, so given augmented matrix is consistent. What do you mean consistent? That means the given linear system has either one solution or infinitely many solutions. Okay, so that means your consistent linear system. So run the solution of the given problem. What is given? We have given augmented matrix. Augmented matrix is. So we have given augmented matrix is. What is your augmented matrix? First row become 1h4, right? And second row become 3 6 8. Okay. So we have to find the value of h. For this, this is your coefficient matrix A, and this is your column matrix of constant. Okay. This is your coefficient matrix your capital A, and this is your column matrix of constant. Okay, so we have to make this coefficient matrix A into upper triangle matrix. So we have to make that diagonal entry become 1. So this already entry become 1. Okay, next procedure we have to make that A2 one entry, that is second row of first element is 0. So how to make this element 0? There is 3. So we have to multiply by this first row by -3, then it become -3, and after it taking addition 3 minus 3 become 0. So what is your row operation? So your row operation become R2 minus 3 times of R1. What is your row operation? R2 minus 3 times of R1. So given augmented matrix become compared to your first row as it is, that is 1 4 1h4. This is your first row as it is. What is your second row? That is 3 minus R2 become 3 minus 3 into 1, that 3 into 1 is minus 3, and 3 minus 3 become 0. So this value become 0, right? So what is the second value is 6. Again 6 minus 3 into R1. R1 is H. So what is this value? 6 minus 3H, right? What is last value? This value is R2 is 8 minus 3 into 4. R1 value become 4. 3 into 4 is 12 and 8 minus 12 is minus 4. Okay. So we have to do this matrix into upper table matrix. Okay. Also we have given, so given argument matrix is consistent. Given argument matrix is consistent. That means the given system has one or infinite solution. That means, so that also we have given augmented matrix. Also we have given augmented matrix. Also we have given augmented matrix is consistent, right? Also we have given augmented matrix is consistent. That is, this is your augmented matrix AB, right? That means rank of A and rank of AB are equal. That means rank of A equal to rank of augmented matrix AB, right? What do you mean by this consistent? That means the given system has one or infinite solution. When this is possible, if the rank of A, this is your rank of A and rank of total AB, both are equal. Okay. That means what is the rank of A? That is the rank means number of non-zero. Here is 2 non-zero rows. And what is the rank of AB? This is total matrix, and this total matrix has also rank is 2, right? There is 2 non-zero rows. This first row, this second row, these 2 rows are non-zero rows. So rank of AB is 2. And for that, so rank of A, we must refer this entry become non-zero, right? Then this both rank are equal because rank of AB is 2. There is 2 non-zero row, and rank of A, this is your coefficient matrix. Its rank is 2. If this entry 6 minus 3H is non-zero, right? That is possible if this 6 minus 3H, this value become non-zero. This value is non-zero, then its rank A and rank AB are equal, right? That is, if rank A is equal to rank AB, if this 6 minus 3H is non-zero, right? That means 6 is not equal to 3H, that means we cancel. That means 2 is not equal to H, right? So therefore, so value of H is not equal to 2. So all possible value of H other than 2 are your value of H. Okay, this is your value of H. Says the following system of the augmented matrix is consistent. Okay, so take one more example by using the system of linear equation. So let us write down the next example. So let us take the third example. Do the 3 lines. Let us question number 3. Do the 3 lines. Do the 3 lines. Do the 3 lines. Your lines in your 3 equation. Your first equation become x1 minus 4x2 equal to 1. Second equation become 2x1 minus x2 equal to minus 3, and third equation become, that is minus x1 minus 3x2 equal to 4. Okay, so your last third equation become minus x1 minus 3x2 equal to 4. So your question is, do the 3 lines, that means 3 equations have common point of intersection. What is your equation? We have given the 3 equations, that is 3 linear equations, in two variables x1, x2, and we have to check that these three lines, that is three equations, have common point of intersection, right? This is your question. Okay. So how to solve this question? So for this three equations, we have to consider the system, right? So now solution. So consider augmented matrix. Consider augmented matrix for a given system. Consider augmented matrix for a given system is, what is your augmented matrix? This is your augmented matrix AB. What is the augmented matrix? Consider coefficient matrix capital A, and we will write down in the right side of matrix A is column matrix of constants. We will write down this matrix B to the right side of A. Okay. So what is your coefficient in the last matrix? What is your first row? 1 minus 4 1. That is 1 minus 4 1. This is your column matrix. Second row become 2 minus 1 and minus 3, right? This is your second row. What is your last third row? So I will write down bigger row. Then so all these are will be 0. What is your first row? This one. Okay. First row become 1 minus 4 and plus 1. Second row become 2 minus 1. Last is minus 3. Last third one become minus 1 minus 3 4, right? Minus 1 minus 3 and 4. Okay. This is your augmented matrix. Okay. Now we have to check that these three equations have a common point of intersection. That means we have to reduce. That means we have to reduce this augmented matrix AB into upper triangular matrix. We have to reduce this matrix into upper triangular matrix. That means we have to make this all these three entry. These three entry we have to make 0, and we have to make all diagonal entry become 1. Okay. So here we have to do first question is we have to make this first element, that is A1 one element 1. This already is 1. So what is next step? We have to make that two element is 0. What is your next step? We have to make that two element, that is A2 1 and A3 one element is 0. So how to make 0? This is 2. We have to multiply. Here is minus 2, then 2 minus 2 is 0. So here is minus 1. After taking addition of third and first row, then minus 1 plus 1 become 0. So what is your row operation? So your row operation become R2 minus 2 times of R1, right? R2 minus 2 times of R1, and third row operation become R3 plus R1. This is your row operation. Okay. So we have to do this row operation on your augmented matrix. So your new matrix become your first row as is. What is your first row? 1 minus 4 1, right? What is your second row? That is R2 minus 2 times of R1. This value is 2 minus 2 into R1 minus 2 into 1, that is minus 2, and 2 minus 2 is 0. Right? This value is 0. Again this minus 1 R2. Again minus 2 into minus 4. Then minus plus 2 into 4 is 8. And minus 1 plus 8 is 7. What is the next value? This value is R2 is minus 3. Again minus 2 into 1. Minus 2 into 1 is minus 2. So minus 3 minus 2 is minus 5. Okay. What is the last operation? That is second operation is R3 plus R1. After taking R3 plus R1, minus 1 plus 1 become 0. So this value is 0. So this minus 3 and plus R1, that is minus 3 minus 4, that value become minus 7. Again this value 4 plus 1, that value become 5. Okay. So this is your new matrix. What is next procedure? We have to make that A to 2 element, that is we have to make that 7 is 1. So how to make 7 is 1? So divide second row by 7, right? Divide second row by 7, right? We have to divide the second row by 7, or we can't divide that 7 now, we can take as it is. So take divide R2 by 7. Then we have to find the common point of intersection. That means we have to find the value of x1, x2, right? So your first value is 1 minus 4. This one 0 upon 7 is 0. 7 upon 7 is 1, and this last value is minus 5 upon 7. And your third row as it is 0 minus 7, and this is plus 5. Okay, this value. So what is next row operation? We have to make that element is 0. We have to make that element is 0. How to make 0? This is minus 7. Multiply by second row by plus 7 and take addition. And then minus 7 and plus 7 is 0. Okay. So what is your row operation? So your row operation become R3, that is minus 7. We have to make that element is 0. So minus 7 multiplied by second row. So that is R3 plus 7 times of R2, right? Then we get element is 0. That is minus 7 and plus 7. After taking addition, then we get 0. So your equivalence matrix become your first row as that is 1 minus 4, and this is plus 1. Your second row become as what is your second row? That is 0, 1 and minus 7 by minus 5 by 7. That is third element. Okay. So what is last third row? We have to do the operation. That is R3 plus 7 times of R2. That is 0 plus 0, 0. Right? 0 plus 0 is 0. Again, second row operation, second element is minus 7 plus 7 into 1, that is 7. Minus 7 plus 7 is 0. Right? So what is the last operation? That is last limit is 5. Okay? So R3 is 5 plus 7 into R2. R2 is minus 5 by 7. Right? So what is this value? Check that. This R3 is 5 plus 7 into minus 5 by 7. Right? So that is R3 is 5 plus 7 into minus 5 by 7. This 7 cancel. I mean 5 minus 5. And 5 minus 5 is 0. So we get last value is 0. So we get this third row become 0, 0, 0. So from the argument matrix, next step is equating the both sides. That means we have to multiply that coefficient matrix A. First element by x1 and second element by x2. Let us equating both sides. Equating both sides, then we get equating both sides, then we get your first equation become x1 minus 4x2 equal to 1. Second equation 0 into x1 is 0. 1 into x2 is x2. So value of x2 is minus 5 by 7. Right? So value of x2 is minus 5 by 7. Okay? So therefore we get value of x2 is minus 5 by 7 and value of x1. Put this value x2 in equation 1, that is above equation, called equation 1, called equation 2. Put equation 2 in equation 1, then we get value of x1 become x1 minus 4 into x2 is minus 5 by 7 equal to 1. Okay? Again this minus plus, minus plus. So 4 into 5, that is 20, right? 4 into 5 is 20, right? And this plus term shift to the right side, then minus term. So we get, see this one, this minus plus, okay? Minus plus. 4 into 5 is 20. So we get 20 by 7. This 20 by 7 shift to the right side, then minus. So value of x1 is 1 minus 20 by 7. So therefore x1 equal to, this is 7. 7 minus 20 is minus 40, right? So we get value of x1 is minus 40 by 7, right? So we get x1 equal to minus 40 by 7 and x2 is minus 5 by 7. Okay? Therefore we get value of x1 and x2. Therefore the given system has unique solution. That means the given system is consistent, right? Therefore, given system has unique solution. Therefore, given system has unique solution. Or after putting this value, we get the both systems are satisfied. That means given system has a unique solution. Therefore, that means given system is consistent, right? Given system is consistent. If system has no solution, then given system is inconsistent. And if system has solution, that is unique or infinity, then given system is consistent, right? So given system is consistent, that means the given system has common point of intersection, right? Therefore system has common point of intersection, right? Therefore system has common point of intersection. Okay, this is your answer. Okay, so I hope all parts were understood. So remaining part we have to study in next lecture. Thank you.